Revolutionizing surveillance, China's SSUAV drone program set to deploy 500 units by 2025. Overview. China is poised to revolutionize its military capabilities with the ambitious deployment of 500 units of its SSUAV drone program by 2025. This initiative underscores China's strategic intent to enhance its unmanned aerial vehicle UAV technology, aiming to match or even exceed U.S. military standards in drone warfare. The SSUAV is part of a broader modernization effort within the People's Liberation Army (PLA), reflecting China's growing military ambitions and technological advancements. Timeline of developments. 1. Recent Pentagon report, December 2024. In its annual report, the U.S. Department of Defense (DoD) highlighted the rapid progression of China's UAV technologies, particularly their advanced systems like the WZ-7 Soaring Dragon and the WZ-8 reconnaissance UAV. The report emphasized that while China is making significant strides in UAV capabilities, it has not yet surpassed the operational effectiveness of the U.S. Air Force. The Pentagon noted the importance of this technological evolution as it indicates a comprehensive modernization of China's unmanned systems across various operational theaters. 2. Introduction of the SSUAV, November 2024. At the Zhuhai Airshow, China unveiled the SSUAV, a drone designed for long-range reconnaissance and potential tactical strikes. The SSUAV's design closely resembles that of the U.S. RQ-4 Global Hawk and MQ-9 Reaper, showcasing China's intent to create a versatile UAV capable of extensive surveillance and combat operations. The drone features advanced technologies that enhance its operational range and effectiveness in military engagements. 3. Emergence of the Feiyi drone, January 2025. Researchers announced the development of the Feiyi drone, which can launch from submarines and seamlessly transition between underwater and aerial operations. This innovative design potentially provides China with a tactical advantage in naval warfare, particularly in contested areas such as the South China Sea and the Taiwan Strait. The Feiyi's unique capabilities signify a shift in military strategy toward integrating UAVs into naval operations. Key themes and insights. Modernization and integration. The primary focus across various sources is China's commitment to modernizing its military UAV capabilities. The integration of advanced technologies, including artificial intelligence (AI), is emphasized as a means to enhance surveillance, reconnaissance, and operational flexibility. This evolution reflects a broader trend in military innovation where UAVs become central to modern combat strategies. Potential U.S. rivalry. The consensus among analysts is that China's advancements in drone technology position it as a direct competitor to U.S. military capabilities, particularly in reconnaissance and tactical operations. The SSUAV program, along with other UAV developments, indicates a strategic pivot in military capabilities that could alter the balance of power in the Indo-Pacific region. Versatile applications. The SSUAV and other drones like the Feiyi are designed for multiple applications, not just intelligence gathering. This versatility represents a significant shift in military strategy as UAVs increasingly serve both surveillance and offensive roles. Such capabilities allow for a more agile and responsive military force capable of adapting to various combat scenarios. Comparative analysis of sources. Focus on specific technologies. While the Pentagon report provides a broad overview of UAV systems and their roles, other publications such as Bulgarian Military delve into the specific design and capabilities of the SSUAV. This highlights the differences in focus, where some sources emphasize technological advancements while others concentrate on the implications of these developments in military strategy. Naval versus aerial focus. The Asia Times article particularly emphasizes the maritime applications of UAV technology and the Feiyi's capabilities in naval warfare. In contrast, other reports focus more on the aerial capabilities of the SSUAV. This divergence illustrates the multifaceted nature of modern military operations where both aerial and naval dimensions are critical. Conclusion: China is on track to significantly enhance its UAV capabilities through the SSUAV program and other advanced drones. This strategic focus on developing versatile and sophisticated UAVs reflects China's military ambitions and signals potential shifts in the balance of power in aerial and naval combat scenarios. As these technologies evolve, they will likely reshape both domestic and international military strategies, particularly in the context of US-China relations in the Indo-Pacific region. Implications for future military engagements. The deployment of the SSUAV and similar technologies indicates a transformative shift in military operations. As UAVs become more integrated into combat scenarios, their role in surveillance, reconnaissance, and direct engagement will be critical. The ability to conduct operations seamlessly across air and sea domains, as demonstrated by the Feiyi, could redefine operational strategies and influence military engagements in contested regions. Strategic considerations. As China continues to develop and deploy advanced UAV technologies, it is crucial for the US and its allies to adapt their strategies accordingly. This may involve investing in counter-drone technologies, enhancing aerial defenses, and developing new operational doctrines that account for the evolving capabilities of adversaries' UAV fleets. The geopolitical landscape in the Indo-Pacific is likely to be shaped significantly by these developments in drone warfare. In summary, China's SSUAV drone program represents a critical advancement in military technology with profound implications for global security dynamics and military strategies in the coming years. The content presented reveals several counterintuitive elements regarding China's SSUAV drone program and its implications for global military dynamics, especially in comparison to US capabilities. Here are some of the identified counterintuitive points. 1. Perceived technological superiority. While the Pentagon report suggests that China is rapidly catching up to US standards in drone technology, it firmly states that China has not yet surpassed the US Air Force in overall capabilities. This implies that despite significant advancements, there remains a technological gap that may not be evident in public discourse, where discussions often tilt toward portraying China as a potential equal or superior competitor. 2. Rapid development versus strategic depth. The rapid deployment of the SSUAV and other advanced drones could create a perception that China is achieving military parity with the US. However, the focus on quantity, e.g., deploying 500 units by 2025, does not necessarily equate to superior quality or strategic depth in military operations. The U.S. military's experience, operational concepts, and integrated command structures may still provide it with a qualitative edge that is not immediately apparent in the sheer number of platforms. 3. Drones as multi-role assets. The SSUAV and the Feiyi drone showcase a strategic shift towards multi-role capabilities, where drones are designed for both reconnaissance and direct strike missions. This dual-purpose nature may suggest a simplification of combat strategies, but it also reflects a complexity in operational planning that may not align with traditional military doctrines. The ability to switch roles or integrate drones into broader combat scenarios complicates the understanding of their effectiveness, as they may not be as versatile in practice as intended. For focus on naval warfare, the emphasis on the Feiyi drone's capability to transition between underwater and aerial operations could lead to an underestimation of its implications for naval warfare dynamics. While the US is also developing similar capabilities, China's advancements in this area could allow it to exert influence in contested maritime zones more effectively than anticipated, potentially reshaping naval engagement strategies in the Indo-Pacific. 5. Integration of AI and civilian technology. The expectation that AI and machine learning will enhance drone capabilities might lead observers to overestimate the immediacy of these advancements. The integration of civilian technological developments into military applications may not be as seamless or rapid as suggested. The reliance on civilian sectors for breakthroughs in military capabilities may introduce vulnerabilities or delays in operational readiness. 6. Underestimating the impact of UUVs. While the report discusses the role of underwater drones UUVs in enhancing China's maritime capabilities, it may not fully capture the transformative potential these technologies hold. The narrative often focuses on traditional military assets, underplaying the significance of UUVs in reshaping undersea warfare and intelligence operations. This could lead to a miscalculation of how UUVs might alter conflict dynamics, particularly in areas like the South China Sea. 7. Potential for overestimation of military readiness. The showcase of advanced UAVs at airshows and their subsequent military adoption may create a narrative of immediacy and readiness that does not reflect the actual operational status of these systems. The timeline for full integration into military operations alongside training and logistical support might extend beyond initial deployment plans, indicating that the perceived readiness of China's UAV capabilities could be overstated. 8. Impacts on US-China relations. The advancements in China's drone technology may signal a shift in military balance, however, the actual implications for US-China relations could be more nuanced. Increased drone capabilities may lead to heightened tensions and an arms race, but they could also push both nations toward new forms of engagement and deterrence strategies that emphasize technology over traditional military confrontations. By analyzing these counterintuitive aspects, it becomes clear that the discourse surrounding China's SSUAV program and its military capabilities is layered, requiring careful consideration of both quantitative and qualitative factors as well as the broader strategic context in which these developments are unfolding. China's SSUAV drone program, which aims to deploy 500 units by 2025, is a significant development in the realm of unmanned aerial vehicle UAV technology, marking a pivotal moment in the military modernization efforts of the People's Liberation Army Air Force (PLAF). While much of the discourse surrounding this initiative focuses on its immediate implications, such as enhanced reconnaissance and combat capabilities, several critical aspects of the program and its broader implications for international military dynamics are often overlooked. Overlooked content and its significance. 1. Integration of AI and autonomy. A crucial yet frequently underappreciated element of China's drone advancements is the integration of artificial intelligence (AI) and autonomous operations into UAV systems. The Pentagon report emphasizes that China is not only developing advanced UAV technologies but is also prioritizing AI-enabled technologies for various military applications, including predictive maintenance, logistics, and automated target recognition. This integration is significant because it suggests a strategic shift towards algorithmic warfare where autonomous systems could operate with minimal human intervention, thereby increasing operational tempo and reducing decision-making times in combat scenarios. The potential for AI to enhance the accuracy of missile systems further underscores the transformative impact of these technologies on warfare. 2. Cross-domain capabilities with the Feiyi drone. The emergence of the Feiyi drone, which can launch from submarines and transition between underwater and aerial operations, epitomizes the increasing complexity and capability of modern military drones. This development is significant as it highlights a trend towards cross-domain warfare where capabilities in one domain, air, sea, or land, are not only integrated but also enhance operational effectiveness across domains. Such capabilities could allow for unconventional tactics in naval warfare, enabling China to leverage its drone fleet to conduct operations that complicate enemy defenses, particularly in contested maritime environments like the South China Sea and the Taiwan Strait. 3. Shift in military strategy. The SSUAV and other drones illustrate a broader shift in China's military strategy towards multifunctional UAVs capable of both reconnaissance and offensive operations. This dual-use nature of drones reflects a strategic evolution where UAVs are envisioned not just as surveillance tools but as integral components of a tactical strike force. The implications of this shift are profound, as it suggests that future conflicts may see drones playing a pivotal role in achieving rapid dominance in air and naval engagements, thus altering traditional power dynamics. 4. UAV diplomacy and global influence. China's advancements in drone technology also have significant implications for its global military influence. The successful development of high-end UAVs positions China as a key player in the international arms market, capable of exporting sophisticated military technologies to other nations. This potential for drone diplomacy could reshape global defense partnerships, particularly in regions where countries seek to enhance their military capabilities without relying solely on Western technology. By offering cost-effective yet advanced UAV systems, China may strengthen bilateral ties with nations seeking to modernize their military forces, thereby expanding its geopolitical influence. 5. Countering U.S. military dominance. While the U.S. maintains a technological edge, the rapid pace of China's UAV advancements poses a challenge to American military superiority. The Pentagon's assessment notes that although China has not yet surpassed the U.S. Air Force overall, its drone capabilities are catching up. This dynamic is significant as it may lead to a re-evaluation of U.S. military strategies, particularly in the Indo-Pacific region, where the balance of power is increasingly contested. The U.S. may need to invest further in counter-drone technologies and develop its own advanced UAV systems to maintain operational effectiveness against a rising Chinese drone threat. 6. Implications for naval warfare. The development of the Feiyi drone, specifically designed for maritime operations, raises questions about the future of naval warfare. With its ability to operate from submarines and conduct air-sea operations, the Feiyi could redefine engagement strategies at sea, particularly in high-stakes regions like the Taiwan Strait. This capability to launch drone swarms from underwater platforms could overwhelm traditional naval defenses and complicate anti-submarine warfare efforts. The significance of this development lies in its potential to shift naval engagement paradigms, making traditional naval power projection more vulnerable to drone-based tactics. 7. Technological innovation and military doctrine. The advancements in the SSUAV and other UAV systems underscore a broader trend in military innovation, where states are increasingly adopting new technologies to reshape their military doctrines. China's focus on UAVs reflects a recognition that future conflicts will require flexibility, adaptability, and enhanced situational awareness. The integration of drones into military operations suggests a shift towards more network-centric warfare, where various platforms work in concert to gather intelligence, conduct strikes, and support ground forces. This evolution in military doctrine emphasizes the importance of technological superiority in achieving strategic objectives. Conclusion. The SSUAV program and its associated developments signify not just an enhancement of China's military capabilities but also a transformative moment in the landscape of modern warfare. The integration of AI, the emergence of cross-domain operational capabilities, and the strategic shifts in military doctrine all point to a future where unmanned systems play a central role in conflict. As these technologies continue to evolve, they will likely reshape not only China's military posture but also the broader geopolitical landscape, challenging existing power dynamics and prompting a re-evaluation of defense strategies worldwide. Understanding these overlooked aspects is crucial for grasping the full implications of China's UAV advancements and their potential impact on global security. 1. Strategic modernization of military UAVs. China's SSUAV drone program is emblematic of a broader strategy aimed at modernizing its military capabilities, particularly in unmanned aerial vehicles (UAVs). The decision to deploy 500 units by 2025 is not merely about quantity but reflects an urgent need to enhance the quality and versatility of its UAV systems. This modernization effort is underscored by the integration of advanced technologies such as artificial intelligence (AI), which will enhance operational capabilities in surveillance, reconnaissance, and combat. The Pentagon's report emphasizes that while China is advancing rapidly, it has not yet surpassed U.S. capabilities. However, the trajectory suggests a significant potential for future competition. This point opens the floor for discussions on military balance, the implications of AI in warfare, and the potential shifts in global power dynamics as nations invest in drone technology. 2. Emergence of multi-domain warfare capabilities. The introduction of the Feiyi drone capable of launching from submarines and seamlessly transitioning between underwater and aerial operations indicates a transformative shift in naval warfare. This drone exemplifies the growing trend towards multi-domain operations where capabilities can extend beyond traditional boundaries. The Feiyi's advanced design allows it to perform reconnaissance and strike missions, potentially altering the tactical landscape in contested areas like the South China Sea and Taiwan Strait. The implications for naval strategies, particularly in the context of US-China competition, are profound. This point merits further analysis of how such technologies can redefine naval engagements and the strategies that militaries may adopt to counter these advancements. 3. Technological rivalry with the United States. China's advancements in UAV technology, particularly with the SSUAV, are strategically positioned to rival U.S. military drones such as the RQ-4 Global Hawk and MQ-9 Reaper. This rivalry is not merely technological but also ideological, signaling a shift in military paradigms where nations seek to assert their dominance through technological superiority. The SSUAV's design incorporates features aimed at enhancing stealth and operational flexibility, which could challenge existing U.S. air superiority. The discussion can delve into the implications of this technological arms race, including the potential for escalation in military conflicts, the need for new defense strategies by the U.S., and the role of international alliances in countering emerging threats. 4. Impact on global military strategy and relations. The rapid development and deployment of advanced UAVs like the SSUAV and Feiyi by China have significant implications for international military strategy and relations. As China enhances its UAV capabilities, particularly with features that allow for reconnaissance and potential strike missions, this may provoke responses from the US and its allies, leading to an increased militarization of the Indo-Pacific region. The geopolitical landscape could shift as nations reassess their defense postures in light of new threats. This point invites discussion on the potential for conflict escalation, the role of diplomacy in mitigating tensions, and how nations can navigate the complexities of an evolving military environment where drone warfare becomes increasingly prevalent. These 4 points provide a comprehensive framework for in-depth analysis and discussion regarding the implications of China's SSUAV drone program and its broader context in global military dynamics. 1. The Cold War surveillance and espionage. During the Cold War, both the United States and the Soviet Union engaged in extensive surveillance operations utilizing various technologies including reconnaissance aircraft and satellites. The US U-2 spy plane, introduced in the late 1950s, exemplified advanced aerial surveillance capabilities. Its high-altitude flights allowed for detailed intelligence gathering over Soviet territory, which was crucial during tense periods such as the Cuban Missile Crisis. The adversarial nature of this period highlighted the critical importance of aerial reconnaissance and intelligence in shaping military strategy and international relations. 2. The Vietnam War and the development of drones. The Vietnam War marked a significant turning point in the use of drones for surveillance and combat. The U.S. military employed the Ryan Firebee, an unmanned aerial vehicle used primarily for reconnaissance missions. These early drones provided valuable intelligence on enemy positions, helping to inform military operations. The increasing reliance on UAV technology during the Vietnam War laid the groundwork for subsequent advancements in drone warfare, showcasing the potential for unmanned systems to alter the dynamics of conflict. 3. The Gulf War's technological revolution. The Gulf War 1990 to 1991 demonstrated the transformative impact of technology on modern warfare. The U.S. military employed a range of advanced technologies, including drones like the RQ-2 Pioneer, which were used for reconnaissance and targeting. The success of precision-guided munitions and real-time intelligence showcased a shift towards network-centric warfare where information superiority became a key determinant of military success. This conflict highlighted the growing importance of integrating UAVs into military operations, influencing future strategies and developments in drone technology. China's SSUAV drone program with plans to deploy 500 units by 2025 represents a transformative phase in military technology, particularly in the realm of unmanned aerial vehicles (UAVs). This initiative is not merely a quantitative increase in drone deployment but is indicative of a strategic shift in China's military capabilities designed to rival and potentially surpass U.S. technological standards in drone warfare. Future predictions. 1. Enhanced UAV capabilities, by 2025. The deployment of the SSUAV will likely mark the beginning of a new era in UAV capabilities. These drones are expected to integrate advanced technologies such as artificial intelligence (AI) for improved autonomous operations, enhanced surveillance, and robust tactical strike capabilities. The incorporation of AI will not only streamline operations but also allow for complex data analysis in real time, making these drones invaluable for intelligence, surveillance, and reconnaissance (ISR) missions. 2. Shift in military strategy. As China rolls out the SSUAV and similar platforms, its military strategy will likely pivot towards a more integrated use of UAVs in combat operations. This could include swarm tactics where multiple drones operate in unison to overwhelm enemy defenses, as well as a focus on multi-domain operations that combine aerial, naval, and ground forces. The potential for these drones to engage in both reconnaissance and offensive operations will enhance China's tactical flexibility in conflict scenarios, especially in contested areas such as the South China Sea and Taiwan Strait. 3. U.S. military response. The advancements in China's UAV technology will likely prompt a strategic rethink within the U.S. military. There may be an accelerated push to develop countermeasures, including attritable drones and advanced air defense systems, to mitigate the threat posed by China's UAVs. The U.S. may also increase investments in AI and machine learning to enhance its own drone capabilities and ensure operational superiority in future conflicts. 4. Global arms race in UAV technology. The rapid development of the SSUAV and China's other drone technologies could trigger a broader global arms race in UAV capabilities. Other nations, particularly those in the Indo-Pacific region, may feel compelled to enhance their own UAV programs to counterbalance China's growing military influence. This could lead to increased defense spending and technological collaboration among allied nations, particularly in drone technology and related fields. 5. Strategic partnerships and export potential. As China continues to develop advanced UAV technologies, its potential for exporting these capabilities to other nations will grow. Countries seeking to modernize their military forces may turn to China for cost-effective UAV solutions, thus expanding China's strategic partnerships and influence in global military markets. This could further complicate the geopolitical landscape, especially in regions where U.S. interests are at stake. 6. Integration of cross-domain operations. The emergence of the Feiyi drone, capable of transitioning between underwater and aerial operations, signifies a trend towards cross-domain military operations. This integration will likely lead to the development of more sophisticated multi-domain systems that can operate seamlessly across air, sea, and land, enhancing situational awareness and operational effectiveness. Such capabilities could redefine naval warfare, particularly in terms of surveillance and strike operations against enemy fleets. 7. Potential for conflict escalation. With enhanced surveillance and strike capabilities, the deployment of the SSUAV could lower the threshold for conflict initiation. The ability to conduct precision strikes and gather extensive intelligence could embolden China in regional disputes, particularly concerning Taiwan and the South China Sea. This may increase tensions with the U.S. and its allies, leading to a more volatile security environment in the region. 8. Technological innovations and cybersecurity concerns. The integration of AI and advanced sensors in UAVs will also raise significant cybersecurity challenges. As these drones become more autonomous and data-driven, the risk of hacking and cyber attacks will increase, necessitating robust cybersecurity measures to protect military assets. Future developments in UAV technology will likely involve creating secure communication channels and countermeasures against electronic warfare tactics. Conclusion. China's SS-UAV program is set to redefine the landscape of modern warfare. By 2025, the deployment of these advanced drones will not only enhance China's military capabilities but also significantly alter the dynamics of global military strategy. The focus on multifunctional UAVs capable of both reconnaissance and offensive operations reflects a broader trend towards integrated warfare in which unmanned systems play a crucial role. As the US and its allies respond to these developments, a new era of military competition centered on UAV technology will emerge with implications for international security and geopolitical stability. The advancements made by China in this domain will likely serve as a catalyst for innovation and strategic recalibration among global military powers, shaping the future of warfare in profound ways.